The question says it's the chances of failing within 1 year is 0.8. So naturally, your X random variable is number of panels failing. So that's what you're focused on. The problem is that when you then get to the question about finding N, so this one leads to the next one. When it says find the smallest number of solar panels required to ensure that the probability the satellite is still operating, you see the wording of it. It says still operating is the opposite. And it makes it trickier to think about is because in order for a solar panel to operate, you only need one. So in the previous scenario, they said you got 10 solar panels, so N equals 10. So in order for it to still operate by the end of the year, you just need one of them. So that means that you can have 9 failing, you can have 8 failing, you can have 7 failing, and that's the reverse thinking. You see, usually you'd say, I need 1 working, 2 working, 3 working, 4 working, 5 working out of the 10. But because your X random variable now is focused on failing, it's the reverse thinking. So the reverse thinking is then, well, if you've got 10, you can't have all 10 failing because then it won't operate. So it works backwards. It goes 9, 8, 7, 6, 5, 4, all the way down, right? That's all the possibilities. When it fails 9, then there's 1 that's still working out of 10. If 8 fails, there's still 2 working out of 10. So you have to work in that region. But when you get to this question, the problem is now you don't know how many solar panels there are. Okay, so the previous one was 10, so then you know you need 9 failing. But if you have M, then how many do you need to fail? This is where you have to model it, and this is essentially saying, well, 10, how'd you get 9? It was at least 1 that still works, so therefore it's 10 minus 1. So in this case, it should be M minus 1, which is a bit more confusing. This is why the method that I showed you guys, or posted in Teams, I approached it this way. So this is the original, using the original wording. If X was the focus of fail, how many solar panels are going to fail? Then in this case, total number of solar panels, I've got M. So I don't know how many solar panels I need, but I know the chance of fail is 0.8. So I'm keeping all the wording the same. So that means my focus, when I say what's the chances of still operating means that the number of fails I need is 1 less than the total. So if the total is M, then it's N minus 1. Now this in itself already is scary, just as you're writing it out and trying to figure out the mathematics to it, right? So here, this actually just means I want the chances of me still operating to be greater than 95%. So 95% of the time, it'd still be operating, right? So here, X less than or equal to N minus 1 is the same thing as saying all fails except 1, minimum. So it means it could be then 8, that means there's 2 still working, 7, then 3, etc. So then I did the reverse. So here, this is where the reverse is. I say, well, working out this one is really hard to do, so why don't we do the reverse? Let's work out if it all fails. 1 minus all fails essentially means still working. Yeah, so 100% minus the chance of it completely failing, that means whatever's left over is all operating. Yeah, fail, opposite of fail is operating. Yeah, so if they all fail, there's only one scenario that's going to all fail, then that means the number of fails I want is exactly the total number of solar panels. Yeah? Does that make sense? Hands up if you're confused with this bit. So if I had 10 solar panels, chances of all 10 solar panels failing means that it's not even operating. So this is 1 minus the chances of it not operating at all. 1 minus the chance of not operating is the same thing as saying chance of still operating. You see, that's where this part here is confusing because it's the wording. You're going backwards and forwards. But once you understand this bit, that this actually still means probability of still operating, why is this more preferable? Is because you can still rearrange this hand method. You need to know. This is what they want you to train for the exam. You need to be able to rearrange this inequality. -1 on both sides, divide by negative, change the inequality, and you get up to this step. Probability of x equals m, so it's binomial now. We know this is the chance of failure. So that means out of M solar panels, I choose M to fail. So I want all of them to fail. Chances of failing is 0.8, so all of them will fail. And then 0.2 is whatever's left over. So n minus n. So total number that minus whatever I'd chosen should be left over. So n minus m becomes 0. What's convenient is when this is m choose m is only 1, 0.2 to the power of 0 is also 1. You end up with an exponential equation. And you do log on both sides. So here you do log base 10, log base 10. Bring the m down, and you get m times log 10 of 0.8 is less than or equal to log 10 of 0.05. The only thing you got to be careful is when you divide this log 10 of 0.8, Joe picked up in the last session that log 10 of 0.8 is a negative number. Anyone remember why? How do we know when you log something it's going to be a negative number? What's the hint?
Because the thing in the brackets is less than 1.
That's it. It has to be less than 1. So think about the log graph. The intercept is at 1. So when you say log base 10 of 0.8, 0.8 is less than 1. So the y value is going to be negative. So when you divide that side, both sides by log 10 of 0.8, it's going to be negative. So when it's negative, you have to switch the signs. Okay, so if you do that, you get to this bit, you can do the log on your CAS calculator, you get 13.4. It just means that M at minimum has to be from 13.4 onwards. The number of solar panels can't be 13.4, so it has to be 14 solar panels at minimum. So what made that question hard? It's this bit. It's the interpretation that your focus was on fail, but you're trying to get still operating, which is the other way around. So what I did was I gave a second method, which this is how I first approached it. I just changed the way you focus it. Instead of using what they gave you, which was X is the focus of fail, then I said, well, why don't we just focus on operating? So I just gave it a different variable. I said, let capital Y be solar panels operating. So if 0.8 is fail, then 0.2 must be success. So it's still operating. So this changes your thinking because then you're only focused on how many do you need succeeding, right? So again, you don't know how many solar panels you have, it's M, but you know you want still operating. So to still operate, you need at least 1. That's a much better way to understand it, yeah? So this one is just saying, yeah, I need 1 operating, 2 operating, 3 operating, 4 operating, 5 operating. So if you were to solve it, this is still operating, but to calculate that, since you don't know how many solar panels, it's infinite. So what we do is we do the opposite again. We say, well, still operating is 1 minus if it wasn't operating. So if it wasn't operating, 0 of them will operate. This would be fail. So chances of fail, 1 minus chance of fail is chance of operating. This is much easier to understand, right? When you do it this way, still the same thing, bring the 1 across, divide by negative, and you end up with something very similar. You end up with this bit, but instead of M choose M, this time you're choosing 0 panels succeeding, so they're all failed, and then 0.2 to the power of 0, 0.8 to the power of n minus 0, and it's the same thing. You end up with the same expression, but it was just an easier way to interpret. So in the exam, you may find changing the variable of focus, the random variable of focus may help you. There is also a difference in when you do it on a CAS calculator. So in my notes, when I sent it to you, if you do inverse binom, the inverse binom, but n, so the one that I posted in our teams, that works only if you know what x is. So in this case, I knew x or y needed to be 0, or at least up to this point. The problem with this one, if you do it this way, that's an m. The choose x equals, that's an m variable. You can't do inverse n. Okay, so by changing the variable, you can do it on this one because you know you're choosing x equals 0. So when you're choosing it, it'll ask you for cumulative probability. It'll ask you for the probability of success. They'll ask you for x, how many you want to choose to fail or succeed. that one you can choose a number. This method, you won't be able to choose a number. Okay, so then you come into a problem. So that means if you do it through this way, you'd have to do it by hand. You do it through this way, you can't do it with a CAS. Okay, so when I showed you guys in it, you can go to inverse norms, so venue, probability, distributions, inverse binom. So notice there's two of them. Yeah, so one is when they give you n, and one when they don't give you n. The one we're currently calculating is we don't have n. Okay, they didn't tell us the number of trials, but they did tell us, or kind of told us, what x equals to. The second problem right after that question is the reverse. They don't give you x, but they give you n. So they told you they have 22 solar panels, but you're trying to solve how many successes you need. That's when you use this binom. So those two are different. Okay. So this one is the one you're using to find n. The one with binom with an n means find n. So here, again, cumulative probability, you just got to be careful. It's always moving from left to right. Okay, so when you looked at your calculations, we want it to be 0.05. So from left to right, it has to be less than or equal to 0.05. So that's why this one's 0.05. Probability of success was 0.2. And the focus of success we want was 0. So this is the first method. So this is the one I'm doing. I'm doing this one. Okay, so I wanted 0 of them, and I want them to calculate number of trials. Probability of success is 0.2, not 0.8, because I've changed the perspective. Yeah, so here we then say put in matrix form. It's just easier to see. And you can see it means that when it's 14, it's going to be less than 5%, which means what we want, which is at least 95% and above, whilst that one isn't. So the answer n is 14. Okay, so the inverse binom n with the capital N there is to find number of trials. Whereas the second problem that you're about to do, this one, that I wrote my solutions to already, that you can have a look, this one's the other way. This one they gave you n. See, the other one we're trying to find n. This one they said 22 panels, 0.8 failed. The problem is you don't know this one. X is greater than what number? So what should X be? What should the number of successes be such that the area or the probability is equal to 0.5429? That's the difference. Again, you still need cumulative. You still need the left-hand side. So you still need to do 1 minus whatever that probability is to get you that. So you still have to do the same thing. The only difference is that one is actually calculating for the number of success. The other one is calculating the number of trials. Okay, so if you have a look back at that exercise 14C, if you haven't done it yet, those are the two things to be wary of. So there's two techniques there. Here's my CAS work. This is binom without the capital N. That's working for number of successes. The one previous, which is the one that had multiple ways of doing, that's finding number of trials. Okay, so just keep that in mind as you're doing these questions, because there is a difference between them. And I know in exams, that's a very typical type problem that will come up. So these two, very good examples for you to practice. Okay? That went on much longer than I thought, but hopefully that gives you a better description than what I did for the first time. Okay, so for the first time when I was explaining it, one is for number of trials, number of successes, and the other one is number of trials. Okay? And obviously, you can also do trial and error. If you couldn't be bothered doing the whole inverse norm thing, you can do trial and error till you get your actual answer. That's okay too. You can do binom CDF and would have been the same. Binom PDF, and you would have got the same thing. Okay? Yeah. Maybe tip for this type of question, you have to learn both. You have to learn both the hand method, so up to this point using log, and you also have to know how to do it with a CAS. So either way, I don't care how, but you have to learn both. Okay? Changing variable or not changing variable, that's going to be up to you on reading the question whether you can problem solve that. Okay? All right, I'm going to stop the video.